Hello everybody, I hope you're having a good set of e-learning days off so far and staying in as much as possible and being safe. Hope you guys are all well. Um, so just as a reminder, the other day we talked about section 8.1, which was similarity in right triangles. And I hope you guys enjoyed that video um, that I posted for you. It gave you somebody else to explain it. So hopefully you found that helpful. As a reminder, I'm always available via email. Please reach out to me if you have any questions or concerns. I'm always happy to help you guys. So today what we're going to be doing is talking about the trigonometric ratios, which are in section 8.2. And very simply, trigonometric ratio is a ratio of two sides of a right triangle. Keep in mind with this chapter, we're really going to be focusing on right triangles specifically, especially in the trig stuff. That's really all related to right triangles. So let's go ahead and get into it. And there's going to be three big functions that we're going to be talking about here. The first one is going to be called the sine function. Usually you will see this abbreviated as SIN. That is still pronounced sine. It is not pronounced sin. So sine. Sine is going to represent, this is going to represent the opposite side over or divided by the hypotenuse. Okay. So what we're going to be doing is looking at a specific angle. Across from that angle or opposite of that angle, we will have a side that's going to be our opposite side. And then the hypotenuse, as a reminder, is always going to be your longest side in a right triangle, which will always be opposite or across from the right angle. So just as an example here, if I draw you a picture. So here's going to be our right angle. Let's say this angle here is represented by the Greek letter theta. Okay. Theta, theta. So here we go. So let's say we're considering this angle. Let's say the sine of the angle theta is going to be equal to. So theta here, if we're looking at theta, this over here is going to be the opposite side, and I'll represent that with O. And then here is the hypotenuse. And across from theta, that's going to be the opposite. And then again, across from the right angle, that's the hypotenuse. So the sine is going to be the opposite over the hypotenuse, and I'll just use O and H there to represent the opposite and hypotenuse. There are two other really big functions we'll be discussing here with the trig stuff. So the next one is going to be called the cosine, which if you're looking on your calculator will be abbreviated as COS. That represents cosine. That's going to represent the adjacent side. Remember, adjacent means next to, over or divided by the hypotenuse. Okay, so let me draw a little diagram again. So consider the same type of picture. Here's our right angle. This is our hypotenuse. Now let's say this is our angle theta again. The adjacent side is going to be this side here. So it's the one that's next to it. You do not have to go across the triangle, you just go right next to it. And then the hypotenuse again is the one across from the right angle. So if we're looking at the cosine of this angle theta, that's going to be the adjacent, abbreviated with A, over the hypotenuse. And I will give you guys a little acronym here in a couple minutes to actually memorize that really, really easily. Okay, so there's the sine and the cosine. the last function we need to talk about with the trig stuff is going to be the tangent function. And the tangent is going to represent, or if you're looking at your calculator, it's going to be represented with TAN. And this is going to represent the opposite side over, or divided by again, the adjacent side. So let's consider that same triangle yet again. Here we go. So let's have our angle theta, and this might also be called x, or some other letter. So here we have theta. Now our opposite side is going to be over here. Our adjacent side is here. So now our tangent of theta is the opposite over the adjacent side. Okay, here are three big functions with the trig stuff. So what you might also see here is different letters to represent these angles. Typically, and I'll just make a note for you here, typically capital letters represent the angles or the vertices. The lowercase letters represent sides. And as usually, we can use the two-letter notation as well if we want to represent a side. So keep that in mind. Now over here, I've used capital letters, but that's just simply for the abbreviations for the different sides. But if you were given a problem, as we'll see in a couple minutes, typically our capital letters will be represented for the angles. All right, so let's go ahead and do an example here. Also, I want to point out, you guys will need to have a scientific calculator for this stuff. Hopefully you've got yours at home. If you don't, Desmos is always a good option for you, or any type of online scientific calculator that's free. Don't go spending money on something online. If you have one, that's great. There are a couple different models that we'll need to deal with. Typically, I'm pretty familiar with the TIs, the Texas Instruments ones. So some of them you can type everything in straightforward. Some of them you have to type it in backwards. But that'll really be coming into play in section 8.3, where we have to worry about those different orders. So let's go ahead and talk about an example here. So let's write the sine of our angle A as a trigonometric ratio. Okay. And then let's just say I have a triangle. Let's say this is A. Let's say this is B and this is C. Okay. So now let's say this one is 3, this one's 4, and this one is 5. And we want to write the sine of A. So the sine of A here is going to be, as a reminder, if we go back to the other paper, the sine is going to represent the opposite side over the hypotenuse. So if we look back at this paper here, we're considering A. So opposite of A, or across from A, is going to be 3. So we're first going to have 3, and then over the hypotenuse, which the hypotenuse is across from or opposite of the right angle. So that's going to be 5. Okay. We could also do the cosine here. The cosine of A is going to be the adjacent side to A, which is going to be 4. And then again, the hypotenuse is still 5. And then if we wanted to find, we could also do, and these are just extra ones, but just to give you guys some extra information here, tangent of A is going to be the opposite over the adjacent, so the tangent is going to be 3 over 4. So there are those 3 different trig functions for this specific example. All right, so I do want to give you guys, before we move any further, I want to give you a quick acronym that will hopefully help you memorize this stuff very quickly. It's called SOHCAHTOA. So here we have 3 letters at the beginning. We have S, C, and T. And as you might guess, this is going to represent sine. This is going to represent cosine. And this one's going to represent tangent. These other letters underneath here, O and H, again, those are going to represent the opposite over the hypotenuse. A and H, those are going to represent the adjacent and the hypotenuse. And then the tangent, we have O and A, which is going to be the opposite over the adjacent. So here's a very quick way to memorize this. Again, SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, one thing I want to mention here, it's kind of sloppy, but there should be an angle here. So I'll just put our angle theta again after all of these. You can't just have sine or cosine or tangent. You have to have sine, cosine, or tangent of a specific angle. And these angles would be numbers as well. So like if you want to type it into your calculator, you might be given a certain number of degrees to type into your calculator. And that's what we'll go ahead and do now. So the next example, we'll just be typing into your calculator. So you might want to pull these out now. One thing to mention, your calculator does have different modes. You might want to locate the DRG button. DRG is going to switch between degrees, radians, and gradians. You want to always be in degree mode for this class. So if it ever on your calculator says RAD or GRAD or R or G, please click that button a couple times to get back to D. So we want to be at degrees. So let's say we want to find, find the sine of 8 degrees. So again, every time you're going to be typing this in your calculator, you should have an actual number here of degrees to type in for your angle. So if you type this into your calculator, you'll just type, there's 2 ways to do this, depending on the calculator you have. If you have the fancier TI one, where it shows you like everything you're typing as you go, then that one you're just going to hit the sign button, and then you're going to type 8 and then equals. If you have the other one, which only shows you as like you have to type a button and then it'll delete what you just typed and then only show you what you most recently typed, that one is going to be, you're going to type the number first, so you'll type 8 and then you'll hit the sign button. Either way, after you do that, you're going to get approximately 0.14. So this is what you should get. Since I'm going through these, please check on your calculator that you get these answers to make sure your calculator is working properly and it is in the correct mode. We can get some other examples. Find the cosine of 76 degrees. If you do this, you should get approximately 0.24. And then the last one, find tangent of 82 degrees, which should give you approximately 7.12. And all of these functions will work the same way when you type them in, depending on what calculator you have. So again, if you have the little bit higher end one, you're going to type just straightforward. You'll type the function, sine, cosine, tangent, and then the number, and then equals. If you have the other one, you type the number first, and then sine, cosine, or tangent button. And these will be approximate. That's what this squiggly equal sign means. These will all probably be very long decimals that don't repeat or anything. They probably will look pretty nasty. But just round to a couple places, that's fine. All right, so the next thing I want to do is talk about using trig ratios to find a length. So let's say this is going to be example 3. Let's say we have a triangle that looks like this. And I've got 6.1 here. And down here I have 41 degrees. And this here is A. This is B. This is C. We want to figure out what the length of AB is. So we're going to be looking for the length of this side down here. All right, so first off, we need to figure out what function we're dealing with. So the angle we're given is angle A, which is 41 degrees. And we're looking for the length of AB. Well, AB is the adjacent side to this angle. And we have 6.1, which is going to be the opposite side of that angle. So if we go back to our little acronym up here, SOHCAHTOA, which one uses the adjacent and the hypotenuse? Or I'm sorry, the adjacent and the opposite. That one's going to be the tangent, which has the adjacent and the opposite. So as we go here, we will have the tangent of 41 degrees. Again, you always need to take a trig function of an angle. That's going to be equal to the opposite, TOA, T-O-A. Tangent equals opposite over adjacent. Adjacent is what we're looking for, which is the length of our segment AB. All right, so now this is going to be an algebra equation we can solve. So now if we solve for AB, we can multiply both sides by AB. AB times the tangent of 41 degrees equals 6.1. And then we need to get AB by itself, which means we're going to need to divide by the tangent of 41 degrees. And after doing this on your calculator, you should get that this is approximately equal to 7.02. Now again, typing into your calculator here. Depending on the calculator you have, if you have the fancier one, you can type this straight in. 6.1 divided by tangent 41 equals, and then it should give you the answer. The other calculator is a little trickier for this one. So here what we're going to do is we're going to type 6.1 divided by 41, then the tangent button, and then equals, and then you should get this 7.02. So try your calculator, make sure you can get to this. Again, this is a fully solved example, so make sure you can get this out of your calculator. If you have issues, please let me know. Let me know what calculator model you have, and I'll be able to help you figure out exactly what the functions are you need to type in. All right, so hopefully this is all making pretty good sense to you guys. If it is not, just reach out to me. I do want to mention, just to end here, a little joke. As I said, although this is marked sin, it is pronounced sign. So I want to mention the biggest sin that you'll create in this section is calling sign sin. All right. So hopefully you guys enjoy my little dad joke. Please be safe and let me know if you have any questions. Have a great day.